Good morning, guys. This video is actually directed to Tolu and Sipe, who requested me to help them with this assignment. So I am making this video trying to explain step by step. So I didn't want to give you guys my assignment without you understanding what is the procedure. So forgive my handwriting. It's like a walking duck. So Person 1, we're given consumer 1 and consumer 2, they are utilities, right? But they're saying each consumer got 6 rand and the price of good X is got 2 and the price of good Y is got 3. So this means combined they've got 220 rand, but don't cover the combination. So, but how do we find the income constraint function? So if you've got 20 rand and you want to buy apple and bread, this means the quantity of apple that you bought times the price of apple plus the quantity of bread that you bought times the price of bread is called the 20 rand, because we spend the whole amount now. So our income constraint functions 2x2, which is the price of good X times the quantity of X, which we don't know, plus 3 times the quantity of good Y, which is called 6 rand for both. So both consumer 1 and consumer 2 has got this income constraint function. But they say calculate the quantity of X and Y which maximize utility. The keyword is maximize, but how do we maximize utility? So we go back and see that when we want to find the maximum position, we always differentiate, right? We check the first derivative is equal to 0. So, but this is the different way. So utility, we said, how do we maximize utility? Maximize utility. So we go back to our first year stuff. We say weighted magnitude of good X is called weighted magnitude of good Y, which is called, so our weighted magnitude of good X is called magnitude of good X over price of X is called magnitude of good Y over price of Y. So that's the point. And we differentiate the utility of first customer with respect to X, and then we divide by the price. So after we differentiate first derivative, we get 0.4 y to the power 0.6 over x to the power 0.6. Don't be confused with my over thing. It's just like times x to the power negative 0.6, because anything to the power negative is called 1 over something that power the power positive, right? So after we divide by price of x, which is called the price of x, which is called 2. So if we divide, this means we invert, right? Because this is a fraction, then invert is good times 1 over 2. So we get 0.2 y to the power 0.6 over x to the power 0.6, which is actually here. So we do the same for y. So we find the magnitude of y, and then we divide by the price of y. So we will find MUY over PY and MUX over PX. And then we equate the two. We say the weighted magnitude should be equal. So when equating, we equate the two, right? So we solve this equation. So to solve this, we cross multiply, right? So 0.2 x to the power 4 times x to the power 6. So we know that when the powers meet, they add, right? So x 0.4 and 0.6 and the y 0.6. This means x to the power 1 and y to the power 1 always give us x and y, right? So we find the equation x is equal to y. So now we've got equation 1, right? And then we go back, we've got this equation and the one for income constraint function, this one. And then we substitute the value of x or of y into this equation. And then we find x equal 12 and y is equal 12. This means for consumer 1, 12 units of good X and 12 units of good Y maximize utility for that consumer. Then we can always check to see if it's maximum. I don't know if this is a requirement for the question, but I just do it. So we do the second derivative. If the second derivative is less than 0, which is the second derivative in X and the second derivative in Y are both less than 0, this means we are maximizing utility. So as you see, I did the second derivative. So this shows that when you did the second derivative, your function will be having a negative at the back. This means whatever you do, this function will give us a negative answer. The same as for y, the function will be having a negative at the back, which shows that whatever you do, you substitute the value of x and y, which is called 12 and 12, it always gives us a negative answer. So we repeat the process for consumer 2. You find MUX, and MUY, which is derivative of mu with respect to x and derivative of u with respect to y, and then you divide by the price of x, divided by the price of y. This is MUX over PX, and this is MUY over PY. So you did the derivative and divided by the price of y, you find this, then you equate the same thing. After equating, you should know that always when you equate and cross multiply, the power in y, if they add those powers in y, so 0.75 plus 0.25, 0.5 plus, they should always give you 1, so that you don't, they don't give you 1, this means you made a mistake somewhere. So we say 0.75 plus 0.25 give us 1, which is 6y is equal to x. So for x is equal to 3.3y. Then you go and substitute in the income constant function, and then you get the value of x and y. Then you can check, as you did, you do the second derivative of the function in x and the second derivative of the function in y, and see that both are less than 0. This means it's the maximum position. Then we move to question 2. Use the Lagrange method multiplier. So the fact that when you're using a Lagrange multiplier, we formulate two equations. We are given the budget 900, we are given the rental rate 4, we are given the wage rate 2. So these are the costs, right? So we find the budget constant function, which is which is the price of capital. 4k plus 2k is called the budget, which is 900, right? After finding the budget constraint function, then the Lagrange method tells us that what is the equation? F of xy, lambda is equal to f of xy plus lambda g of xy. But our g of xy, this is the function. So you take 900 on the side, it gives us 4k plus 2k minus 900 is equal to 0, right? And then you substitute in this formula. This means our f of xy is the equation that we're given, 25k to the power 0.4, L to the power 0.5, plus lambda 4k plus 2k minus 900, right? Which is, you substitute the second function after sg of xy. Then you solve, it's not solving, it's simplifying. You simplify, then you get q squared 25k. Lambda we multiply by 4k lambda by 2l lambda, lambda by 900 minus lambda. Then now you've got a function. But what we need now is dq with respect to k, because now we've got l, k, and lambda. You differentiate q with respect to k, with respect to l, with respect to lambda. So dq over dk, you get this one, dq over dl, you get this one, dq over the lambda, you get this one. Then you've got three equations, 1, 2, 3, right? And you have to solve these three simultaneous equations to find the value of L and K. Then you make L the subject of the formula in equation 3, which is the one that does not have lambda, this one, right? So we make L the subject of the formula, so we get L is equal to 450 minus 2K. We substitute the value of A in equation 1 and equation 2, in both equation 1 and equation 2. So if you substitute in the equation 1, we get this one is equal to minus lambda. If we substitute in the equation 2, we get this one is equal to minus lambda. But lambda is lambda, right? So equate the values of minus lambda. This is the value of minus lambda, and this is the value of minus lambda. So this one should be equal, where is it? Where am I now? Okay. That one, we say this one should be equal to this one. Both are minus lambdas. So after equating the two equations, you cross multiply. Just take this one, find the 50 minus 2k is like x. So we said when the power meets, when the coefficients are the same, 450 minus 2k, they are the same, right? And then when the power meets, they add. So 0.5 0.5 plus 0.5, it gives us what? 1. So this means we'll be having 2.5 times this one, the power 1, which is the same thing. And if these powers meet, the power 6 and the power 4, if they meet, they just give us k the power 0.4 plus 0.6, which is k the power 1, which is k. So we'll be having like 6.25 k. And then now it's simple, we solve this equation and find k. You can just, after finding k, you go back to the equation 3, right? When you say L is equal to 450 minus 2k, you substitute the value of k, you get L is equal to 250. And you can, now if you got k and L, substituting into any equation, you can find the value of lambda. And now the question says, find the maximum output. Output is Q, right? So, but our production function is, our production function is this one. Q is equal to 2.5 k the power 0.4, L the power 0.5. Then substitute the value of k and L. Our k was 100. Our L is equal to 250, and substituting this into this equation, and we'll find our value of our output, right? So we say our k is equal to 100 to the power 4, 250 to the power 0.5, and then we find our k. I just did round mine. So 100 units of capital and 250 units of labor gives us the maximum yield or output of 2494 units. So we'll be done with question 2. Then question 3, they say the demand function, given the demand and supply function, we know how to calculate equilibrium. At equilibrium, PD is equal to PS, right, which is the price, and Q is equal to QD is equal to QS. So you solve for Q and for P, and I won't tell you how to solve this because you know. Then after solving for P and Q, for you to understand, you have to draw some kind of graph, right? So if we draw a graph of supply, it gives us this one. It gives us this line, right? And the graph of demand, it gives us this line. But our equilibrium is called 60 price and 80 quantity. But you know our consumer supply is the area above, right? Which is this one in zebras. And our producer supply is called this one. Now, we don't count the area below at the which is in the negative region. This one is not part of our producer supplies. And then the area for our producer supplies is this one. Follow my cursor. This one. This is the area of our producer supplies, right? But for us to find first consumer supplies, you should understand what do we mean by integration. So if we are given a line like this, ignore let's say that we don't have this PS value, this line. If we are given a line like this, and you are told to find the area, if we integrate this line, the demand equation, 100 minus 0.5 Q, between 0 and 80, we get the area of this trapezium. So we get the area bound between the line 0 and 80 to the line, right? So from 80, you go and touch the line, and from 0, you go and touch the line. And the area that is bound between the line and the 80 line and the x-axis and the 0 line is the area that we integrate on. When you move, if we integrate between 0 and 200, this means we get the area between the line, the 0 line, and the x-axis, right? So if we integrate the demand function, we get this area, right? But which one is remaining? Which one do we want? We want this triangle only, this one. But now we get this one, right? If we integrate, we get this trapezium. Then trapezium minus the area of this rectangle. We know that area of this rectangle is what? 60 minus 80. This means we get this area, right, of this rectangle. This means area of a trapezium minus area of this rectangle will be left with this one in zebras. So we integrate our demand function between 0 and 80, between 0 and 80, minus area of this rectangle, 60 by 80, to get our consumer surplus, which is the remaining areas in zebra. So if we integrate, we substitute by value of 80 into this equation and substitute by value of 0. If you substitute by value of 0, you get 0, right? So there is no need for us to substitute 0. Minus this one, and then we get our consumer surplus. Let's go back to our producer surplus. Which one is our producer surplus? Is this area, right? But how do we count for this area? So for us to find this area, right, we say area of this rectangle 60 by 80, it covers this whole area. But we have included the area that we don't want, which is this one, this triangle. But to find this area of this triangle, we integrate the supply function. But now it's not between 0 because we want this area, né? It's between 20 and 80. So we integrate, we say the area of the rectangle, which is 60 by 80, will get 4,800 minus the integral between 20 and 80 of the supply function. So if we integrate the supply function, we get this one. So for you, some of you may not understand what do you mean by integrating between 20 and 80. So we substitute the value of 80 into this equation and solve. The answer we get, we subtract when we substitute by 20. So when substitute by 80 into this one, we get minus 1,600. 80 into this one, we get 200. What we get minus when we substitute by 20. 20 into this one, minus 400. 20 into this one, we get this one. So if you substitute, we get this value. So our producer surplus is called this minus the integral of the supply function between 80 and 20, which is minus 800, and then we get our producer surplus. So analyzing the consumer producer surplus, if the supply function shifts down to PS 0.3, but first, if the supply function shifts, the equilibrium percent changes as well. So we cater for the change. We calculate the new equilibrium percent with Q is called 9 and P is called this one, because we've got the new supply function and the demand function is still the same. The demand function should be both at the new supply function. Then after calculating the new equilibrium percent, I try to draw for you. So if we draw, now our equilibrium percent is got a price of 56.67 and 86.67. And now we do the same. We calculate the consumer surplus. But this area is bound between 0, not now is not 80, between 0 and 86.67. And this is we get the area of this trapezium, which is integral of the demand function between 0 and 86.7, between 0 and 86.7, minus area of this rectangle with dimensions width and length 56.67 and 86.67. So when you substitute by 86.23, it will be 0.67, but I just put a 2 over 3 for me to be accurate. And then we simplify and we get this answer. The producer surplus is still the same technique as we applied earlier. We got the graph. We say producer surplus is this one, right? But this one is area of this rectangle minus area of this triangle. So area of this rectangle is 56.67 times 86.67. Area of this triangle is the integral of this supply function between 30 and 86.67. So it's the integral of the supply function, area of the rectangle minus area of the integral of the supply function between 30 and 86.23, which is 67, 2 over 3. I put it in the fraction. So you solve this one. As I told you earlier, you first substitute by 80 by the bigger number minus the answer you get when substitute by the smaller number. First you substitute by the bigger number, the answer you get, you subtract the answer that you get when you substitute by the smaller number. And the answer you got, you subtract from the rectangle. So this is the area of a triangle and this is the area of a rectangle. And then we get our producer surplus. So I set my time to